Alright, so I'm going to begin by stating the following theorem, which appeared in the top of our quiz. And the theorem was that if f of xy, so if f of xy is a function, with f's of x, y, and f's of y, x continuous, then we have the following. We have that f of xy is equal to f of yx. In other words, the partial of f in respect to x followed by the partial of f in respect to the resulting partial in respect to y is equal to the partial of f in respect to y followed by the resulting partial in respect to x. Okay, so this is known as Clairaut's theorem. And so our quiz begins with this theorem, which was stated on top, just, you know, for the sake of stating it. And so the next question in our quiz is question number 1. It says, question number 1 is the following. It says that if using limits, so it says, question number 1 says, using limits, right, explain why the function f of xy equals to x squared y plus 3xy plus 1, okay, is continuous at the point 2, 3, is continuous at the point 2, 3 in its domain. So recall. So let me actually. So let me remind you that. So recall that f of xy is continuous at AB, right, if the limit of f of xy as x comma y approaches AB is equal to f of AB. So that's the definition of continuity in terms of limits. Okay, so there it is. So what I have to say then is, well, so note that limit as xy approaches to the point 2, 3 of the function given above here, of the function given here, f of xy equals x blah blah blah, there you have it. It's just going to be is just going to be equal to 2 squared times 3, okay, times 3 plus 3 times 2 times 3, okay, plus 1. And of course, this implies then, thus this implies that f of xy, which is equal to f evaluated at 2 and 3, okay, is continuous at the point 2, 3. So that's all you have to say. Of course, we know that the domain of polynomials is the whole plane, polynomials in 2 variables. So and polynomials are continuous in their entire domain, the whole plane. Therefore, this is actually quite obvious, but I just wanted you to go through the definition because I wanted you to know that definition, and this was actually sent to you as a preparation question in my email, where I listed a few problems that you actually had to know for the quiz, and this was one of them. Not exactly this particular problem, but a similar question was asked. Alright, so that's 1A. Now let's go to 1B, right? So 1B, question 1B. So let me go to question 1B now. So 1B is here, and question 1B asks via the first partials, so via the first partials, okay, explain why or why not, explain why or why not, right? F of xy, okay, equals to x squared y plus 3 times xy plus 1, the same function as above, okay, is differentiable in its domain, is differentiable in its domain. Okay, so let's take the first partials of the function f of xy. So the partial of f in respect to x, so let me do this in another color here. So let's see. So let me do this in let's see what color I chose up here. Okay, I'll do this in purple. So answer. So we know that it is sufficient for a function to have continuous partials, okay, so we know that if the function has continuous partials, continuous first partials, partial of f in respect to x and partial of f in respect to y, if they're continuous in a region, in an open region, then the function is actually differentiable there. So now let's find the first partials of this function. So the partial of f in respect to x is just going to be equal, okay, to 2 times x y plus 3 times y. So that is a polynomial, and as we stated above, polynomials are continuous throughout R2, the plane. So this is going to be a continuous function throughout the plane. So this partial is continuous throughout the plane, R2, the domain of the function f of xy, blah 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 blah, equals x squared y plus 3xy plus 1. Now let's take the second partial, the partial of f in respect to y. The partial of f in respect to y is going to be equal to, let's see over here, it's going to be equal to x squared, okay, plus 3x, and if we observe, again we get a polynomial, and obviously this is going to be continuous throughout the plane. So the partial of f in respect to x is continuous throughout the plane. The partial of f in respect to y is continuous throughout the plane. Therefore, the function f of xy equals to x squared y plus 3xy plus 1 is actually differentiable everywhere in the plane. So this is what you have to say. Alright, so now what I want to do is I want to go to the other questions. Let me actually increase the size of this. Okay, so I have now question number 2. Question number 2 is quite basic. So let me begin with this yellow. So this is question number 2, and question number 2 says let f of xy equal to yx cubed plus e to the x, y x cubed plus e to the x minus sine xy. Okay, minus sine xy, right? And they want us to find, so they want us to find the partial of f in respect to x. Okay, so answer, well, the partial of f in respect to x, so f sub 1 or f sub x is just going to be equal to, this is the same notation, I'm sorry, not the same notation, but this means the same of f sub x, f partial of f in respect to x, the same story. So in respect to x, I'm finding, the partial of this. So it's going to be 3y x squared, then plus the derivative of e to the x, well, that's just e to the x times the derivative of x, which is 1. So e to the x minus the derivative of sine is cosine minus cosine of x times y. I actually wrote this incorrectly there. Okay, this is not x comma y, this is x times y. Okay, times the derivative of this here in respect to x. This is x times y. Let me see if I can actually change that, because I don't want you to get confused later on. Okay, so can I change this? Yeah, this is x times y, so be careful there. Okay, so let me go back to my red over here. Okay, so there it is. So now I have to take the derivative of this in respect to x. Okay, so that's just going to become, the inside is just going to become y. Now the partial of f in respect to y is f sub 2, this is just the derivative of this expression here of f of xy in respect to y, so it's just going to be equal to x cubed plus, this disappears because it only has x in it, so that disappears, and then we have sine, the derivative of sine. Well, I have to actually get rid of that plus there. Okay, so the derivative of sine is cosine, so minus cosine of x times y times the derivative of this inside here in respect to y, and that is just going to be x. Okay, so what do they want us to do? I said they want us to find the partial of f in respect to x. That was part A, and part B was, okay, I actually did part B without telling you what I was doing, so this was part B. Sorry. This was part B. They want you to find the partial of f in respect to y. There you have it. Now, using the theorem one above, so the theorem that we did before was this theorem over here, so they want us to use this theorem. Remember the theorem here. Let me actually circle it for you, or square it, or whatever. So using this theorem, they want us, the theorem says that if f of xy is a function with f of xy and f of yx continuous, then f of xy is equal to f of yx. Okay, so they want us to use this theorem according to them. Okay, so the question goes, this is question number, part C of question number 2, which is very, very easy. Okay, so part C says, okay, so part C says, using theorem 1, which I just read over there, so using theorem 1, right, above, find, right, f of xy minus f of yx plus e to the x squared y squared. Okay, so according to theorem 1, which I'm going to go over here, so let me copy this theorem. Okay, I'm going to copy this theorem here, so, and I'm going to paste it over in the other region. Okay, so edit, okay, so let me go to the next page. So theorem 1 says this, okay, so there's theorem 1 for you. Okay, so using theorem 1, okay, theorem 1, right, we know that this are the same, so this implies right away we get that this implies, okay, this implies that f of x y minus f of yx is equal to 0. Therefore, this implies that this thing over here, okay, this expression here, okay, this expression here is just e to the x squared y squared. This is actually e to the x squared y squared. Now, you could have gone to taking the partial of f in respect to x and then taking the partial of the resulting partial in respect to y, and taking the partial and subtracting from that the partial of f in respect to y, and then taking the resulting partial, okay, in respect to x, okay, and you would have gotten that I was equal to 0, but you just had to use the theorem, and I just wanted to make sure that you knew that theorem, which is known as Clairaut's theorem, and that's it. So this is it, and that's the answer to the quiz. Thank you for listening.